discuss Euler methods. As we know that Euler method is a single step method, means in a single step we find the value of a point-wise solution, means value of a y1, value of a y2 and value of a y3. By numerical method, to solve any ordinary differential equation, we are not going to find out exact relation between dependent and independent variable. We are going to find out a point-wise solution. Means for given differential equation, first order differential equation, here first we discuss about Euler's method. Euler's method. So, what is the standard form? Standard form, what is the given? Given dy by dx equal fxy. This will be the first order differential equation, and initial condition be the yx0 equal y0. Means so the value of a y at x equal x0 is a y0. This one is a given. So first we give the geometrical interpretation of a Euler method. Then we give the mathematical derivation of a Euler method. Then we solve some numerical example based on Euler methods. So what is the geometrical interpretation of a Euler method? Geometrical interpretation of a Euler method is what? Means suppose any function is a given. Means this one is a, and here once again let me clear, means we find the point-wise solution. Means we find x0 y0, x1 y1, x2 y2, x3 y3 and so on, not any function. Suppose this one is the actual solution. This one is the actual solution. This one is the actual solution. Y equal gx is a suppose actual solution. And this is what? This one is a given at initial value. This one is the initial condition y0, and coordinate of this one is x0 and y0. So here this one is a given, means find the value of a solution at x1. So here we consider this one on an equal class interval. So what is the value of x1? x1 is the x0 plus h, and this is what? This is a second point x2, and this one equal to x0 plus 2h. The distance between this one is h, and class interval here h. So what is our aim? Our aim is to find out this value, means a y1, this value. So how we find this value? So in a single step method, with the help of these two information, means that the value for y at x0 is a given and differential equation is a given. With the help of these two information, we find the approximate value nearer to the what? Nearer to the y1. So we approximate the function which is nearer to the solution. So in case of Euler method, we assume that that function is a what? That function is a tangent that we draw at this point. Tangent that we draw at this point. Then this tangent is assumed as a solution of a given differential equation. And here by putting in this equation of a straight line, by putting x equal x1, we find the value, approximate value of a y. So here there is a y1 approx value, y1 approx value, and this one is a y1 actual value, approx value, y1 approx. This one is a y1 actual, and deviation of this one is a what? Error. Means a y1 actual minus y1 approx give the error. So this one is a concept, means geometrical interpretation, how we find approximate value, means a point-wise solution. Point-wise solution means a point at x equal x1. And similarly, if we have a point, this approximate value, then again we draw the tangent at this point with the help of a slope given, means the differential equation which is given in the form of a slope. We draw the straight line again here. We draw a tangent at this point. Now, if we draw the tangent at this point, then in this tangent is assumed as a solution of this differential equation. And if this tangent is assumed as a solution of this differential equation, then in this tangent we put x equal x2. We put x equal x2. Then we find what? Then we find y2 approx. Y2 approx. Y2 approx. And this one is a what? This one is a y2 actual. Y2 actual. So in this way, again we draw the tangent at this point, and find the next value of the solution, means a y3 approx. So this one is a way, means how we find the approximate solution with the help of a Euler method. So mathematically, how we derive this one? So mathematically, it's not a very tough, means it's a very easy to find out the equation of a tangent, because one point is a given, x0, y0 is a given, and dy by dx is a given. And we know that, means a mathematical derivation. Here we write mathematical derivation. Mathematical derivation. So now we find the equation of a tangent at this point. So equation of a tangent become what? Y minus y0 equal dy by dx at x0 y0 x minus x0. This one is the equation of a tangent. So we write in place of a dy by dx, what is the value of a dy by dx? fxy. So dy by dx equal fxy. So here we write y minus y0 equal f of x0 y0, because the value for dy by dx is a fxy, and dy by dx at x0 y0 is a f of x0 y0, x minus x0. Now we assume that this one is a solution. In case of Euler method, we assume that this equation of a tangent is a solution. Then how we find the approximate value? By putting x equal what? X equal x1. We put x equal x1, putting x equal x1 or x0 plus h. So what will happen? This become y minus y0. Here we write first this factor, so this become x0 plus h minus x0 f of x0 y0. After simplification, this one cancel out. What is the value? Y equal y0 plus h f of x0 y0. Y equal y0 plus h f of x0 y0. And we assume that this one is a what? This one is a value of a y, and we assume that this one is a solution of a this RD differential equation at x equal x1. So we write in place of a y, this one is a what? y1. The value of a y is nothing is at x equal x1, get the solution. So this one is a what? This one is a y1. Now again, in a similar manner, we have a 2 points x1 and y1. We draw the tangent at this point and putting x equal x2. Then we find what? Then we find y2 equal y1 plus h f of x1 and y1. So this one is a approximate value of a y2. In a similar manner, after n plus 1th iteration, what is the value? Yn plus 1 equals yn plus h f of xn and yn. So this one is a what? This one is a iterative scheme of a Euler methods. This one is a iterative scheme of a Euler methods. So now what's happened in a modified Euler methods or modified Euler method and improved Euler methods. So first we discuss some theoretical concept of a improved Euler method and modified Euler method. Then we solve a numerical example using Euler's improved Euler methods and modified Euler methods. Now what will happen in our improved Euler methods? Improved Euler methods. Improved Euler methods. Improved Euler method. Euler method. Which one is also known as a what? Which one is also known as a Hume's methods. Hume's method. Because this one is developed by, this one is modified, improved by the Humes. So due to this reason, this one is called Hume's method. Now what's happened in a Hume's method? So Humes find the average of a, means a tangent at average slope of a at x0, y0 and at x1, y1. What is the meaning of this one? In a Hume's method, suppose this one is a actual solution like Euler methods. Here, this is the initial value x0 and this one is a x0, y0, x0, y0. So in this method, means in an improved Euler method which is developed by the Humes, he draw the tangent at this point like a Euler methods. Draw the tangent at this point. Then at x1, find the value of a y1 with the help of this tangent. With the help of this tangent. Value of a y1 means v. In this method, we find the value of a y1 using the Euler methods. So once we find the value of a y1, then we have two values, means x0, y0, x1 and y1. Then we find the slope at x0, y0 and slope at x1 and y1. Find the average of these two slopes. So what is the slope at x0, y0? Means the slope at x0, y0 is a what? This one is a what? F of x0, y0. F of x0, y0. And slope at x1, y1. And y1 can be found with the help of Euler methods. So is a what? F of x1, y1. F of x1, y1. Then he find the average of these two slopes. Average of these two slopes is a what? Average of these two slopes is a f of x0, y0, f plus f of x1, y1 divided by 2. Then he draw the tangent with this slope. In an Euler method, we draw the tangent with this slope. Slope at x0, y0. But in an improved Euler method, we draw the tangent at this slope. Means the average of a slope at x0, y0 and slope at x1, y1. Now what is the equation of a tangent? So what is the equation of a tangent? So if we talk about the mathematical derivation of a what? Mathematical derivation of a improved Euler method means the improved Euler method, improved Euler method, Euler method, improved Euler method, improved Euler method. So what is the equation of a tangent with this slope? Average of a two slope. So this become what? Y minus y0 means here at this point y minus y0 equal slope. What is the slope? Slope become f of x0 y0 plus f of x1 y1 divided by 2 x minus x0, x minus x0. This one is the equation of a tangent at x0 y0. But what is the slope? Slope is this one, means the average of two slopes. So if we simplify this one and putting x equal x0 plus h or x1, so we find what? We find the value for y1. y1 become y1 equal, if this y0 goes in means we substitute this y0 move to the right hand side, then this become what? This become y0 plus x0 plus h. This become what? x0 plus h minus x0 become h. H inside this become what? This become f of x0 y0 plus f of x1 y1, f of x1 y1 divided by 2, so this become outside h by 2, y0 h by 2. Now y0 h by 2, here how we find the value for y1 here? We find the value for y1 with the help of a Euler method. So if we write this one in terms of x0 y0, this become y1, because this will create means a confusion. This one y1 by the Euler methods, y1 by the Euler method. So y1 become y0 plus h by 2 inside this become f of x0 y0 plus f of, we write x1 as x0 plus h, y1 y0 plus h f of x0 y0 by the Euler methods. So this one is the what? This one is the first approximate solution, means the first value of the solution at x equal x1. So if we generalize this one, means yn plus 1 become in a similar manner, yn plus 1 become yn plus h by 2 f of xn yn plus f of xn plus h and yn plus h f of xn yn. So this one is a what? This one is a iterative scheme of improved Euler methods. This one is a iterative scheme of improved Euler method. This one is a iterative scheme of Euler method. This one is a iterative scheme of improved Euler method. Geometrically, what will happen? Either the error will decrease or increase. So at x1 y1, what is the slope? Slope at this point is this one. This one is the slope at x1 y1. Means equation of a tangent. Tangent at this point, and this one is the slope. Slope is this one. So if we take the slope average of these two, slope at this point, slope at this point, average of these two, and find the tangent at the average of these two slope. So obviously this one lie between this point and this point, means with above the slope of x1 y1 and below the slope of x0 y0. This one is what? Average of these two slope. So what is the equation of a tangent? Equation of a tangent must be passes between these two points, these two straight line. Not here. Sorry, not here. Between these two straight line. This tangent, and this tangent. Because here this one is a tangent of a average slope of a tangent of x0 y0 and tangent of x1 y1. Then obviously this one is a y1 by the Euler method and this one is a y1. This one is a y1 by improved Euler method, means by improved Euler method. This y1 is by the Euler method and this y1 is the actual value. This y1 is the what? Actual value. Then obviously improved value of a y1 lie between actual value and value that we find with the help of a Euler method. Then obviously this one is closer to the actual value in comparison of y1 that we obtained with the help of Euler methods. Then obviously in an improved Euler method we get the value for y1, y2 more closer to the actual value. So that's why this one is called what? This one is called improved Euler method and this one is developed and defined by the Humes. Due to this reason this one is also called Humes method. Next we are going to discuss about modified Euler methods. So what's happening in a modified Euler method? First we give the geometrical interpretation and how this one is different from the Euler method and improved Euler methods. So among the authors there are means a little bit confusion, means someone says Humes method is a modified Euler methods and polygon method is a improved Euler method. Someone says Humes method is a improved Euler methods and polygon method is a modified Euler method. So there is a little bit confusion, means improved and modified. But in most of the books, Humes method is treated as an improved Euler methods and polygon method is treated as a modified Euler methods. So now we discuss about modified Euler methods. Now we discuss the modified Euler methods, which one is also known as polygon methods. So first we give the geometrical interpretation, means what is the difference between Euler's and modified Euler's methods. So in a modified Euler methods, first we find a point at x0 h by 2, means x0 at x1 there is a midpoint, means x0 plus h by 2. We find this point with the help of equation of a tangent of means the equation of Euler method, with the help of Euler methods. So by the Euler method, what is the value of y? Iterative scheme of Euler method y1 equal y0 plus x minus x0 f of x0 y0. This was the equation of a tangent. Y equal this one. Now if we put x equal x0 plus h by 2. x0 plus h by 2, then this become y at x0 plus h by 2 equal y0 plus x0 plus h by 2. If we put x0 plus h by 2, this become h by 2 f of x0 y0. This one is the value for what? This one is the value for y x0 plus h by 2. Now we find the slope at this point. So what is the slope at this point? Slope at this point become what? F of x0 plus h by 2, and because dy by dx is a what? Dy by dx is a f of xy. So in place of x we put what? x0 plus h by 2, because we try to find out the slope at x0 plus h by 2. F of x0 plus h by 2, then we write what? Y at x0 plus h by 2. This one is a y0 plus h by 2 f of x0 y0. Now this one is a slope at this point. Slope at this point. Slope, this is the what? This is the slope. Slope at x0 plus h by 2, x0 plus h by 2, and y at x0 plus h by 2. So now we draw the tangent with this slope. This one is a what? This one is a nothing, is we find the approximate value of y with this slope. So what is the equation of a tangent? Now equation of a tangent with this slope become what? Equation of a tangent with this slope become y1 equal y0 plus what? y0 plus x minus x0 become h. What is the slope? Slope become this one. F of x0 plus h by 2, x0 plus h by 2, and y0 plus h by 2 f of x0 y0. x0 y0. So this one is a what? This one is a slope. This one is a slope. So if we generalize this one, what is the iterative scheme? Iterative scheme become yn plus 1 equal yn plus h f of xn plus h by 2 yn plus h by 2 f of xn yn. So this one is the what? This one is the iterative scheme of modified Euler methods. Iterative scheme of modified Euler methods. This is the iterative scheme of modified Euler methods. Iterative scheme of modified Euler methods. And geometrically what will happen? Here, what is the slope? If we draw the tangent with the slope at this point, then this one is a look like, this one is the equation of a tangent. This one is the equation of a tangent. So this one is the actual value, this one is the approximate value by the Euler method, and this one is the approximate value by the modified Euler method. And the value with the help of a modified Euler method lie between the value of value that we obtained by the Euler method and actual value. Then obviously this one is closer to the actual solution, then the error that occurs by the Euler method is larger in comparison of an error that we obtain if we solve a numerical problem using the modified Euler methods. So this one is what? This one is all about Euler methods, improved Euler methods, and modified Euler methods. Suppose we solve dy by dx equal x plus y, given that y0 equal 1, find solution, find y at 0.2. And here, for sake of simplicity, we assume that h is a what? 0.2. You may also assume h equals 0.1. Sometimes this one is a given, means what is the value of h. So solve this one, means this equation by the, first we solve first by the Euler's method, then by the improved Euler method, Euler method, Euler's method. Then third one, modified Euler's method, modified Euler's method, Euler's method. And as we know that by the Hume's method or polygon method, sometimes this one is also written by the Euler's method, by Hume's method, by polygon methods. So this one is a dy, but this one is a numerical example. Now here we use the iterative scheme of Euler method. What is the iterative scheme of Euler method? Euler's method. Euler's method. So what is the iterative scheme of Euler methods? Yn plus 1, Yn plus n, 1 equal Yn plus h f of xn y, f of xn y. So if we compare here with the given problem, means with the standard result means dy by dx equal fxy yx0 equal y0. So what is the value of fxy? Fxy become x plus y. And what is the value of x0? x0 equal 0 if y0 equal 1. Now in our iterative scheme of Euler method, we put n equal 0. For n equal 0, y1 equal y0 plus h f of x0 and y0. H is also given. Here we write h equal 0.2. So what is the value for y1? Means the y at 0.2, which one is also known as the y1 equal y0. What is the value for y0? y0 is a 1 plus what is the value for h? 0.2 f of x0 plus y0 means x0 plus y0, x0 plus y0, and we know that what is the value of x0? 0 plus 1, this become 1. So what is the value? This become 1.2. So y at 0.2 is a what? 1.2. This one is also known as a what? y1. This one is by the Euler's method. Now by the improved Euler methods, what is the solution? By the improved Euler methods, Euler method, improved Euler method, what is the solution? So first we write down the what? We write down the iterative scheme of a improved Euler method. So what is the iterative scheme of an improved Euler method? Yn plus 1 equal Yn plus h by 2 inside average of a means f of xn yn plus f of xn plus h yn plus f of xn yn, f of y xn plus h yn plus h f of xn yn. So this one is a iterative scheme. This one is a iterative scheme. Means this one is a value x1 and this one is a value y1. So this become what? This become for n equal 0. What is the value? y1 equal y 0.2 means y at 0.2 equal y0 plus h by 2 f of x0 y0 plus f of x0 plus h and y0 plus h f of x0 y0, f of x0 y0. So by putting all the values, means we have a value for x0, y0, h, and we have a value for f of xy. So what is the value? Y0 become what? 1 plus h is a 0.2 divided by 2 f of x0 y0. F of x0 y0 become x0 plus y0. So x0 plus y0, x0 plus y0 plus f of x0 plus h. x0 be the 0, 0.2, and y0 be the 1 plus 0.2 f of 0 and 1. So this one is the value. So if we simplify this result become 1 plus 0.1 inside the bracket. What is the value of x0 plus y0? 1 plus, this becomes 0.2, this becomes 1.02, 1.2. So this becomes x plus y, this becomes 0.2 plus 1.2. This becomes what? This becomes 0.2 and this becomes 1.2 because this f01 become 1. F01 become 1. So 1.2, this become 1.4, this become 1 plus 0.1 plus 1.4, this become 2.4 multiplied by 0.1, this become 1.24. This one is the result at y 0.2. So this one is the result by the improved Euler methods. So improved Euler method, what is the result? So here we write the values of by the improved Euler method. What is the result? Here we noted down the result. Y 0.2 equal what? 1.24. 1.24. And now, what is the result by the modified Euler methods? Now, if we find the result by the modified Euler methods, first we write down the iterative scheme of modified Euler methods. So this one is the result by the improved Euler methods. So not here we write, here means y 0.2 equal what? 1.24 by the improved Euler methods. Now by the modified Euler methods, modified Euler's method, which one is also a polynomial method. First we write what? First we write a iterative scheme of this method. What is the iterative scheme of this one? Yn plus 1 equal yn plus h inside. Slope is a what? Slope is a f of x0 plus h by 2 and y0 plus h by 2 f of x0 y0. Not here. Here this one is x actually. Here we write a n in term of a n. X and y. This one is the iterative scheme. This one is the iterative scheme of a modified Euler methods. Once we verify the result, yn plus 1 equal yn plus h, f of xn plus h by 2, yn plus h by 2, f of xn y1. So this one is a modified iterative scheme of a modified Euler method. So for n equal 0, y1 become y0 plus h inside bracket f of x0 plus h by 2, y0 plus h by 2 f of x0 y0. So by putting the values of x0, y0, h and f of xy, this become y1 equal y0. What is the value for y0? Y0 become 1 plus h is a 0.2 inside f of what? F of x0 here, f of x0 plus what? F of x0 plus h by 2. x0 be the 0, h by 2 means 0.1, 0.1 comma y0 be the 1 plus 0.2 by 2, 0.1 f of 0, 1, 0 and 1. So if we simplify this one, this become what? 1 plus 0.2 f of 0.1 comma this one f01 become 1 because x plus y this become 1. So multiplied by 0.1 this become 1.1. And what is the value? Value at this point become 1 plus 0.2, 1.1 plus 0.1 because this one is x plus 1, this become 1.2 into 1.2 multiplied by 0.2, this become 0.24, and what is the result? 1.24. So this one is the result by the modified Euler method. So by the modified Euler method, what is the value of y0.2? y0.2 become what? 1.24. This one is the result. This one is the result. Y 1.24. This one is the result by the improved Euler method, and this is the result by the Euler method. This one is the result by the Euler method. So this one is the result by the Euler method, this one is the result by the improved Euler method, this one is also a result by the modified Euler method. Now what is the actual solution? So because if we have a actual solution, then only we compare what is the error. So what is the actual solution? So it's very simple, means what is the actual solution? Actual solution. If we talk about the actual solution, so this one is what? This one is a very simple differential equation. dy by dx equal x plus y and y0 equal 1. So this one is a what? This one is a linear differential equation. So if we simplify, if we write this differential equation in this form, dy by dx minus y equal x. So how we solve this linear differential equation? What is the integrating factor? Integrating factor become e to power minus x into e to power minus x. So what is the solution? Y into e to power minus x equal integrate x into e to power minus x dx plus c. After solving this one and putting the initial condition, we find the solution. And what is the solution? Y equal, after solving this one, we find the solution y equal 2 into e to power x minus 1. This one is the actual solution. Actual solution of this differential equation. 2 e to power x minus 1. This one is the solution of this differential equation with this initial value. Now we try to find out the actual value of a y at x equals 0.2. So y at 0.2 equal 2 into e to power 0.2 minus 0.2 minus 1. So after simplification, I have already noted down the value for this one. Y 0.2 equal 1.24280. 1.2424825. 1.2482242, not here, 242. So this one is a what? This one is a actual value. This one is a actual value. Actual value. Actual value. So this one is a what? This one is a solution by the Euler method. This one is a solution by the improved Euler method. This one is a solution by the modified Euler method, and this is the solution by the actual integration, by solving the actual differential equation. So if we closely observe these four solutions, first, second, third, fourth, that we obtained by the Euler, modified Euler and improved Euler method, we observe that the solution that we obtained by the improved and modified Euler method is more closer to the actual solution in comparison of a solution that we obtained by the Euler methods. And how we find the error? Obviously, absolute error, positive difference of actual value and approximate value. Means actual value that we obtain by solving the differential equation and by putting x equals 0.2, then we find the actual value of a y at 0.2. Then approximate value, either with the help of Euler method or improved Euler method and modified Euler method, we find the approximate value. So then we find the positive difference, this one gives the error. In error, after solving any differential equation by Euler method, improved Euler method and modified Euler method. So this one is all about this lecture. In the next lecture we discuss how we solve any ordinary differential equation using a Taylor series solution methods and Picard successive approximation methods. Then we discuss about multi-step methods. So these are the single steps methods. So this is all about this lecture. Thank you. Thank you for watching my video.